Hello Precalc students, this is Mr. Kashi speaking. This will be our second video on sequences, our chapter 9 section 4. This slide, what we want to be talking about is if we have an infinite sequence, whether it converges or diverges. So you can take a look at these different sequences and you can see how this sometimes it's easier to see it in decimal form. 1 divided by 1, well, that would just be 1, and then 1/2, this would be 0.5. 1/3, that would be 0.3 repeating, and 0.25. And so we have two options. We can either converge it's going to converge to a number, or it's going to diverge to infinity or negative infinity. And for A here, you can hopefully you can see how this is decreasing, but if we were to go down to like 1/100, we're going to get really close to 0, but we're never going to get there because we're going to have that really large number in our denominator. So this would be something that we'd say it converges, and it converges to 1, converges to 0. Converges to 0. It's going to get close, very close to 0, but it'll never get there. And then for B, you can see 2 divided by 1, that'd be 2. 3 divided by 2, this would be 1.5, and this would be 1.3 repeating. This would be 1.25, and then you can see how if we were to keep going in B, this is not going to go to positive infinity or negative infinity. This is going to converge to 1. Okay, so it's going to get very close to 1, but it's never going to get there. And here for C, you can see we're just adding 2 each time. We're starting with 2 and we're adding 2. And if we were to keep going, that would diverge, and that would diverge to infinity. It's going to keep going up and up and up and up until go on to infinity. And then for D is a little bit different. This is what we call a geometric sequence. You multiply by -1 each time. It goes up to +1, it goes down to -1, it goes up to +1. It's going to keep going back and forth, so it doesn't converge on a number. We just say it diverges, but it doesn't diverge to anything, so we just say that's the empty set. Okay, so sequences can either get really close to a number and never get there. I should say infinite sequences can get really close to a number and never get there, or it could keep going up to infinity or keep going down to negative infinity. Now we have to talk about our main topic of what we call arithmetic or geometric sequences. And this is these two are the recursive formulas for arithmetic and geometric. Okay, so we have a of n equals a of n minus 1 plus d. This is recursive for arithmetic. And basically this is the number before, and then this is what we call the common difference. Now that just tells us the number that we add or subtract by each time. And so obviously if d is greater than 0, our sequence is increasing, and if d is less than 0, we are decreasing. And then for our geometric, recursive geometric, now we're multiplying each time. So once again, a of n minus 1, this is just the number before, so we just take the number before it, and then we multiply, and this is what we call a common ratio. Common ratio. And so if we have r is greater than 1, we're increasing. And if r is between 0 and 1, we're decreasing. Then something really kind of weird happens. Is if we're on the negative side, so if we go from negative infinity to 0, it's actually going to alternate because we're multiplying by multiply by a negative number. It's going to be positive one time, and then it's going to be negative, and then it's going to be positive, and it's going to be negative. We'll talk a little bit more about those in detail later on. And so I want to go through a couple of examples here, and I just want to go through 2 examples, but I also want to talk about the explicit formula for each as well. Explicit for arithmetic, we would take our 0 term and then add our common difference, and for our geometric, we would take our 0 term and we would multiply our common ratio and raise it to the power of n. So here, if we had this first sequence, hopefully you can see that we are adding 4 each time. That is our common difference. And we need to go back 1 for a of 0. So a of 0 is going to be the term before our first term. So if we're adding 4 each time, this is going to be 2. So our explicit formula for this would be 2 plus 4n. And we'd say a of n equals 2 plus 4n. That would be explicit. That would be the explicit formula. And for recursive, we would say we start with a of 1, we start with 6, and then we just say a of n minus 1, which means just take the number before it and add 4. So the difference between explicit and recursive is you start with the first term with recursive, where you start with the 0 term with explicit. And then here in a geometric sequence, you can hopefully see that we're multiplying by 3. If we go back here, this would be 2/3. That's our a of 0. So for explicit, we would have a of n equals 2/3 times 3 to the n. And for our recursive is a little easier to kind of spell out. We just talk about our first term, which was 2, and then we just say a of n minus 1, and we're multiplying by 3 each time. All right. So if you could use those same techniques for the next 4 problems, the arithmetic are on the left and the geometric are on the right, and we will be able to have conversations about these types of sequences later on in class.